Hello, my name is Catherine Nguyen. I'm a student at Old Dominion University, and I'm completing a series of demonstration videos for microcontrollers and embedded-based designs as part of my senior project. In this video, I will demonstrate the operation of labs number 5 and 6, ADC conversions and voltage range display on LCD module. This lab utilizes the built-in LCD connections on the trainer board to interact with the provided LCD module. The PIC analog to digital converter is used to read voltage values from one of the potentiometers on the trainer board. Objectives of this lab are to read real-time voltage values using the full available resolution of 10 bits. These values must be tested against the predetermined ranges and the results printed on the initialized LCD. Up on the screen I have the basic LCD schematic provided in the lab documentation. The LCD can be controlled with only 4 data lines, but here I am using all 8. You may notice that there are 14 pins on the schematic and only 12 pins on the trainer board. VDD and VSS are already implemented on the trainer board for you via the SV1 socket. The ranges used for this demonstration are shown here. The high range includes values of 4.5 and above, medium range values fall between 2 and 3 volts, and low range values are those below 1.5 volts. Outside of these ranges, the LCD should read unknown. Both the LCD and potentiometer are implemented on the trainer board, so generally all that is required for them is to add the appropriate jumpers between the correct terminals. As always, double check that your switches, namely S1 and S4, are configured correctly based on the number of pins on the PIC you are using. Reference the appropriate manual for the revision of the trainer board you're using if needed. I'm using the 16F877A with a Rev 3 trainer board and have S1 1 to 5 on and 6 to 10 off. For S4 I have 1 on and 2 off. Oscillator connections are required for this lab. The connectors share a terminal with port E for this PIC and are connected directly to the oscillator circuit implemented on the trainer board via SV4. The LCD will need to be inserted into SV1 and connections made from the X29 terminals to PIC I/O. In this case, 8 lines from port B are used to control the LCD. Next we have the register select and enable lines. I have used 2 pins from port C to control these lines. Finally, the voltage reference and read-write lines must be connected. The voltage reference required varies by LCD module, and you will need to verify what's needed for your specific LCD. In my case, the voltage reference and read-write lines are connected to -5 volts and ground respectively. For the potentiometer, connections should be added from +5 volts and ground to the outer pins. The center pin should be tied to the PIC I/O. Here I'm using one of the ADC compatible pins on port E. Not shown here are multimeter connections required to monitor the voltage in real time. I have connected the red lead from my multimeter to the center pin of the potentiometer using the breadboard. The black lead is tied to the same ground as the outer pin of the potentiometer. The program is set up such that it will begin reading and testing values immediately. And so once power is applied, I can immediately begin adjusting the potentiometer to test my program. I have adjusted the potentiometer beforehand to ensure that the first reading was 0 volts. As is obvious from the multimeter reading here, I'm continuously adjusting the potentiometer. A new reading is taken every 5 seconds and the LCD updated. We expect anything below 1.5 to be in the low range, so I've paused a few times here to verify that everything is working correctly. At approximately 1.5 volts, we expect it to switch from the low range into the unknown range, and I'll pause here to verify that that occurs. I'm continuing to adjust the potentiometer, but slowing down here as we approach the low end of the medium range. I'm not expecting the LCD to update to medium until we cross the 2 volt threshold. I'm pausing again here to verify that the lower end of the medium threshold is operating as expected. In here I'll continue to adjust the potentiometer until I near the upper medium limit. You'll have calculated your resolution, so you'll be able to pause at appropriate places to ensure that everything is working flawlessly. And here, as the design specified, we go above 3 volts and the LCD displays unknown instead of medium. And here we'll continue to adjust the potentiometer and observe slowing down as we near the lower threshold of the high range. Everything from 4.5 volts to 5 volts is considered in the high range, so we'll watch as we adjust the potentiometer up to the highest possible voltage to ensure that we remain in the high range. I have calculated my resolution to be on the order of millivolts per step using the ADC resolution and the total voltage range. Hence, I tested my program by adjusting the voltages to be very near the edges of the ranges. You should be able to verify that any given number between 0 and 5 volts is read correctly and bucketed into the correct range. This concludes the demonstration of labs number 5 and 6. Please see the associated documentation for additional information and instructions.